Dear friends, welcome to the lecture of ordinary differential equations, and in this lecture we shall see or we shall solve some problems on formation of differential equation. How to form a differential equation from a given relation, that we shall study in this lecture. So actually we have to form the differential equation by eliminating arbitrary constants in the relation, and if the relation contains one arbitrary constant, then once the differential equation will be first order, and that means we have to differentiate only one time the given relation. And if the given relation contains two arbitrary constants, then we have to differentiate two times and we will get a differential equation of second order, like this. So that depends on the number of arbitrary constants, and there are two types. One is formation of differential equation. We have to first study, then we shall study solution of differential equation. And actually these will be opposite or inverse process of each other. To form a differential equation, we have to differentiate the relation, and to solve a differential equation, we have to integrate the differential equation. So here I have written some problems. We shall solve these one by one. The first is form the differential equation by eliminating the arbitrary constants from the following relations. So here I have written four relations. First is y is equal to c sine inverse x. So solution for this problem. First, the given relation is y is equal to c into sine inverse of x. Now here we can recognize which is the arbitrary constant. C is the arbitrary constant, and in general we are considering y as dependent variable, x as independent variable. That means the variables are y and x. So remaining will be treated as constants, and y is equal to c sine inverse x is the relation. So it contains one arbitrary constant. We shall suppose that relation as 1, and we have to differentiate this with respect to x. So differentiate with respect to x. So what we shall get is derivative of y, that will be dy by dx, and on the right side c is constant. So what is the derivative of sine inverse x? We know it is 1 divided by under root of 1 minus x square. And now we can see the derivative of sine inverse x we have written. So we can transfer this number, this x term, on the left side, or multiply both sides by under root of 1 minus x square, and that gives root of 1 minus x square into dy by dx is equal to c, and that this is the second relation. So we can eliminate now the arbitrary constant by the original relation and the relation obtained or the equation obtained by differentiating it. Now to eliminate, so here we have obtained the value of c directly. C is root of 1 minus x square into dy by dx. Now we shall put this value of c in this equation, first relation, and that gives, so that will be, so putting this in 1 we shall get. So putting this value in 1, we get, see, y is equal to, and this is the value of c we have, that is root of 1 minus x square into dy by dx. This much is the value of c into sine inverse x. So this is the differential equation that we have obtained. So is the differential equation of 1. Or this is the required differential equation. So that is the procedure. It contains one arbitrary constant, differentiate once, and then eliminate the arbitrary constant from 1 and 2. Now we shall consider the second. Second relation is xy is equal to, xy is a into e power x plus b into e to the power minus x. We shall suppose this as 1. How many arbitrary constants are there in this equation? So we can see a and b are arbitrary constants. So therefore we have to differentiate this two times. So differentiate this with respect to x. That gives now the derivative of the left side. So we have to use the product rule. It is x into y. So that gives x, derivative of y is dy by dx, plus derivative of x is 1 into derivative of y, derivative of x is 1 and y as it is equal to, this a is constant, derivative of e power x is same, e to the power x, and b, derivative of e to the power minus x is e to the power minus x into derivative of minus x, that is minus 1. So which is minus e to the power minus x, and therefore the second term is minus b e to the power minus x. We can consider this as relation as second. So this is the derivative either side we have obtained. You should note it. And because there are two arbitrary constants, we have to differentiate it 2 times. Again differentiate. So differentiate again with respect to x. And now we should observe the left side. Term by term we have to write the derivative. So derivative of x into dy by dx, that we have to write. So I shall write here itself. So derivative of x into dy by dx using product rule, that is x first term as it is, derivative of dy by dx is second order derivative, d square y by dx square, plus derivative of first, that is x, is 1 and second as it is dy by dx. So this much is the derivative of x into dy by dx, plus 1 into y means y, derivative of y with respect to x is dy by dx. And on the right side, this much is the derivative of the left side. On the right side again this term is a into e power x. A is constant, derivative of e power x is same as e power x, and this derivative is minus b e power minus x into minus 1, derivative of e raised to minus x, e raised to minus x into minus 1. So that minus 1 and this minus becomes plus. So plus b into e power minus x. So this is our third relation that we have obtained. So every time we differentiate, we get an equation and we number that equation. So this is second and this is third. Now we have to eliminate a and b from 1, 2 and 3. So that is the elimination procedure. So eliminating arbitrary constant, we have to find or form the differential equation. Now how to eliminate a and b from this? Either in the first example we have obtained the value of the constant and then we have substituted the value of the constant in the original relation. But here we can see this is the first equation, second equation this sign becomes minus, and in the third equation again it becoming plus. So that means it is same as the right side of 1. So therefore we can put this value of the right side equal to xy from first relation. 1 and 3 can be used. So this is the right side of 3, which is same as the right side of 1, and that is equal to xy. So from 1 and 3 we get this side we shall keep as it is, x left side, x into second order derivative of y with respect to x, plus this dy by dx plus dy by dx becomes 2 times dy by dx, and this is from 1 equal to xy. So this is the differential equation of second. This is the solution of second. This is the differential equation of the relation 1, or this is the required differential equation. So thus we have solved 1 and 2. Now third is, so you should solve. I will leave third for you to solve. Here there is only one arbitrary constant, that is c. So once differentiation is sufficient, and that the order of the differential equation is 1. So it is easy. Differentiate, we will get dy by dx is equal to derivative of x is 1. So it is c, and that means that gives direct value of c, that is dy by dx. Put that value of c as dy by dx. we shall get this answer. And for the fourth, so it is in terms of cos, and so there are two arbitrary constants. Now you note here the arbitrary constants here are a and b. M is not arbitrary constant. M is the coefficient of x that remains the same. So we need not eliminate M. So we should keep M as it is. So note here a and b are arbitrary constants. Or sometimes the instruction will be given form the differential equation by eliminating the arbitrary constants a and b. Here a and b are arbitrary constants. So this example is similar to the example second that we have. So for what is dy by dx? It is a, derivative of cos is minus sine. So minus a sine mx plus b into m. And again differentiate, that will be in terms of cos. So therefore it will be easy to eliminate a and b from 1 and 3 like this, exactly similar to the second. So you should solve third and fourth yourself. Now we will consider the second example. Find the differential equation of all parabolas, each of which has a latus rectum 4a and whose axes are parallel to x-axis. So that type of parabolas, differential equation we want to obtain. Now parabola whose latus rectum is 4a and whose axis is the x-axis is, and whose vertex is at the origin. So that type of parabola is the standard parabola, and we have, it is of this type. Axis, its vertex is the origin. Then its equation, axis is a x-axis and it touches y-axis. Its equation is y square is equal to 4ax. This is the standard parabola, but it is not the standard parabola. Has latus rectum same, but axes are not x-axis, parallel to x-axis. So that means they have the axis like this. And if you consider that parabola here, so that means the parabola having axis parallel to x-axis, suppose this is, that will be the parabola. And here it is a is the vertex, and if suppose the coordinates of a are alpha, beta, then the equation of this parabola will be y minus y coordinate, that we have to shift the origin from this point O to this point A. So y becomes, what is the standard equation of the parabola? Y square is equal to 4ax. And if we shift the origin, here the vertex is the origin, and if we shift the origin to the point alpha beta, because it is not given that the vertex is the origin, vertex may be anywhere, only the condition is given for the axis. Axis is parallel to the x-axis. So this is parallel to the x-axis, and its equation will be, if we shift the origin to the point A, then y becomes y minus beta square and is equal to 4a, x becomes x minus alpha. So this is the equation of the parabola, and we should have to start with this equation. And see, there are two arbitrary constants, alpha and beta. A is not arbitrary constant, that is given. 4a is the latus rectum. So we shall write the equation of the parabola. Let the vertex be alpha beta. Let the vertex of the parabola, let the vertex of the parabola be a alpha comma beta. For example, we have denoted the coordinates by Greek letter alpha beta, and it is, its axis is parallel to x-axis, and latus rectum is 4a. It is given. Therefore its equation is y minus beta whole square is equal to 4a into x minus alpha. We shall consider this relation. So here what is difference in the earlier problem and this problem? Here the relation is given, here we have to write the relation. Some standard from geometry, we have to write the equation of parabola, and that is this one. So we suppose this as 1, where alpha and beta are arbitrary. Point can be changed anywhere which is parallel to the x-axis. The point on the line axis is parallel to the x-axis, where alpha and beta are arbitrary. Arbitrary constants. Now differentiate 1. Differentiate 1 with respect to x. What we shall get? Derivative of y minus beta square. That is 2 times y minus beta into derivative of y dy by dx by chain rule. It is a term in y. First differentiate with respect to y, multiply by dy by dx. And on the right side 4a is constant and derivative of x is 1, alpha is constant, derivative is 0. So it is only 4a. Or that can be simplified as y minus beta into dy by dx is equal to divide by 2 on either side, that is 2a. And we shall suppose this relation as second. So we have differentiated once, but because there are 2 arbitrary constants, we have to differentiate 2 times. Again differentiate this. Differentiate again with respect to x. So what we shall get is the derivative of this. See, by product rule, y minus beta, first as it is, derivative of this is second order derivative, d2y by dx square, plus now derivative of first. What is derivative of this? Again derivative of y is dy by dx, beta derivative is 0, means derivative of y minus beta is dy by dx into dy by dx. So that is, or I shall write dy by dx into dy by dx. And right side a is a constant, fixed constant, latus rectum, half of latus rectum, and that, but the derivative is 0. So this is the relation that we have obtained, and we shall suppose this dy by dx into dy by dx, I shall write square of dy by dx. And we shall consider this as the third relation. We have to eliminate a and b, not a and b but alpha and beta. Alpha and beta are the arbitrary constants from 1, 2 and 3. Now we can observe, see, the third relation contains only y minus beta. If you eliminate y minus beta, then we will get the differential equation. Now how to get the value of y minus beta? The value of y minus beta can be obtained from second relation. See, from this y minus beta will be 2a divided by dy by dx. So we can make use of second relation in third. So that I shall write here. From 2 we have y minus beta is equal to y minus beta is 2a divided by dy by dx. Now we put this in 3. Putting this in 3. We get, that is 2a divided by dy by dx. Y minus beta we are writing as this one into d2y by dx square plus dy by dx whole square is equal to 0. Now we should express the equation without fraction. Now derivative should not be at the denominator, and therefore multiply again by dy by dx. So multiplying by dy by dx, what we shall get? So this derivative term eliminates and we get 2a into d square y by dx square plus, and we are multiplying by dy by dx, so this power becomes 3 dy by dx cube is equal to 0. So thus this is the required differential equation of the parabolas having axis as parallel to x-axis and latus rectum 4a. So this is the required differential equation. Now the next problem is similar to this, or find the differential equation of all circles which pass through the origin and whose centers are on the x-axis. First we have to form the equation of that type of circles. So circles pass through origin and they have the axis on the x-axis. They have the center on x-axis. So we should draw a figure, then we can find the equation of that type of circle. See, this problem you should solve, and but suppose this is a circle, and this is a circle we have drawn, and its center is on x-axis. Center are on x-axis. So that means this is the x-axis. This is the center. And a point on the x-axis is of the form a comma 0. So some x coordinate will be there, but y coordinate is necessarily 0. And this circle passes through, another condition is this circle passes through the origin. So therefore the origin we should have, suppose a is positive, then origin must be here. It passes through origin. So that means it touches actually the y-axis. This is the y-axis and this is the origin. So this is the figure for the circle passing through origin and having center on x-axis. Now we can easily write the equation, equation of this circle. So let first you have to write, let center be a0, now because it passes through origin, what is the radius of this circle? OC is the radius, and it is the coordinate of x coordinate of C is a, therefore this must be a, distance OC must be a, and its radius is a, and by center radius form we can easily write the equation of the circle. Its equation is, so what is the center radius form that we know is x minus x coordinate of the center, that is x minus a whole square, plus y minus y coordinate of the center, that is 0 whole square, is equal to radius square, or this is x minus a whole square plus y square is equal to a square. So this will be our relation, algebraic relation, and we have to form the differential equation for this relation. How many arbitrary constants are there? Only a arbitrary constant is there, and the one is there is only one arbitrary constant, which is a. So therefore it is sufficient to differentiate it once and then eliminate the arbitrary constant. So you do the remaining steps yourself, differentiate it only once, not 2 times, once, and this is the required differential equation, that first order differential equation, because there is only one arbitrary constant. Differentiate it and eliminate a, that means we have to obtain the value of a and put it here itself, then this equation will be obtained. So you try the remaining steps yourself and get the answer as like this. So this is about formation of differential equation. Remaining part we will continue next lecture. Thank you.